A telephone handset contains a transmitter and a receiver. When a person speaks into the mouthpiece, the transmitter produces a varying electric current that fluctuates according to the pattern of the sound waves. When the signal reaches its destination, the telephone's receiver converts the electric signal back into sound waves, and the listener hears a duplicate of the speaker's voice. Telephone signals can travel almost instantly around the world through a vast network that includes computers, cables, radio receivers and transmitters, and satellites. Most telephones connect with the network by means of wires that run through the walls of houses and other buildings. Dialing a telephone number generates a sequence of pulses or tones that travel to a local telephone office. There, computers use the signals to find a path through the network to route the call between the caller's telephone and the receiver's telephone. Next, the signals that make up the telephone message are sent through a series of telephone stations that direct or switch the path of the signal. These switching stations may be connected by tremendous lengths of cable buried in the ground or laid along the bottom of the oceans. There are two main types of telephone cable. In one type, copper cables, telephone messages travel as electric signals along wires. In the other type, fiber optic cables, telephone messages travel in the form of pulses of light through bundles of hair-thin glass fibers. Messages are also transmitted through the telephone network through the air on short radio waves. In such transmissions, a dish antenna at a relay station receives a signal, and another dish antenna retransmits the signal to the next station. A series of relay stations can direct radio signals over vast stretches of land. To direct radio signals across oceans, the network uses artificial satellites in orbit above the Earth as relay stations.